Hello friends, this video on Haloalkanes and Haloarenes part 14 is brought to you by examfear.com. No more fear from exam. Write the structure of different dihalogen derivative of propane. So we have the normal propane. Now in this I have to add chlorines. What are the possible ways? One possible way is I can add one chlorine here and the another chlorine. Let me try to let's suppose I have added one chlorine here. So other chlorine I can add here in the same carbon, right? Or I can add here in this carbon, or I can add it here. So let me add these three possible options, right? So in one case I'll add in the same carbon, I'll add in this carbon, and I'll add in this carbon. Three possible options. Any other possible? Yes, we can add in these two carbons. Instead of last two carbon, let's add in these two carbon. Any other possibility? I don't think so. Yeah, this is the only four possibilities of dihalogen derivative of propane. You can add all the extra H here. The question says, amongst the isomeric alkanes of molecular formula C5H12, identify the one that on photochemical chlorination yields one single monochloride, and the one that yields 3 isomeric monochlorides, and the one which yields 5 isomeric monochlorides. So let's see what are the possible structure of C5H12. So one is this guy, 5 in a straight chain. One is this guy, right? One is, I have 1, 2, 3, 4. I have chain here. 4 possible options I have. Correct. So let's see if I try with this guy first. This looks very much symmetrical. So in this, if I add chlorine and the chlorine replaces only one hydrogen, so what are the possible product? Only one, because this it cannot replace. It has 4 methyl group attached. You can replace any of this chlorine here and it gives only one product, right? So in this case, this yields only one product. So if you say single monochloride is nothing but this guy. Right? So this will give single monochloride. Let's talk about 3 isomers now. So let's take any of these. Let's take this. So in this, what are the possible options? I can replace carbon here, I can replace carbon here, I can replace carbon here. If I replace carbon here, it is all same as this carbon, double one. I replace carbon here, this is same as this carbon. So there are 3 possibilities, right? 3 possibilities mean 3 possible isomers. That means this is the structure of C5H12 I am looking for. So this gives me 3 monochloride. Correct. And then I have 4 isomeric monochloride. Let's see this guy. So in this, I have one possibility here. These two are same. One possibility here, one possibility here, and one possibility here. There are 4 possible options. Correct. One possibility of any of these, one possibility here, one here, one here. So this will yield 4 monochloride. So with this, I think this solves the question. So we have 3 different isomers of C5H12, that is pentane, and the first one yields 1 monochloride, the second one yields 3 monochloride, and the third one yields 4 monochloride. Here we'll write the product. So we have seen this reaction SOCl2. What it does, it will replace OH with chlorine, right? This reaction we have seen. So this will become chlorine. Correct. Here HCl also we have seen. This will replace this OH. This will become CH2Cl, and this OH will be back. This NAB, I have seen this. This is the reaction, halogen exchange reaction, right? This happens in the presence of acetone. So with this, you get CH3 CH2I plus NaBr. Actually, this is a equilibrium reaction, but then we'll consume this because this precipitates out easily and we'll get this as the product. So let's see this. This I have the reactant with the bromine in presence of light, free halogenation reaction. It will replace any of the hydrogen here. So it can be any of the hydrogen here. N2. So let's say it replaced this hydrogen. It can also replace any hydrogen in this guy. Let's take this guy. HI, it's addition reaction because alkene here, right? So hydrogen will attack first in this position. Why? Because it will form a cation, more stable here, 3 degree. So it will be H here and this will be a cation here. On this cation, my I minus will attack and it will form this compound. Correct. Since again bromine in the presence of light, so one bromine can be attached anywhere. It can attach here or anywhere. It can attach here or it can attach here. Any of these it can form. So we write the equation of formation of 1 iodobutane from butanol, 1 chlorobutane and butene. So what we have to form is iodobutane with chlorobutane. This is what we have to form. So 1 butanol. So I have 1, 2, 3, 4. This is what we have. So in this I have to replace OH. What I can do is I can use HI and I have to use ZnCl2 because it's a primary, right? Primary alcohol. So this will be my SN1 reaction. Sorry, SN2 reaction. So this I will kick off this OH, right? It will form 1 iodobutane plus water. The next is from 1 chlorobutane. 1, 2, 3, 4, 5. I have a chlorine here. So what I can do is I can use this reaction now, ion exchange reaction. I'll use NaI. So this will be equilibrium reaction. It will form I here and NaBr. So this happens in the presence of acetone, right? And this will precipitate out. So this reaction will move in the forward direction. This is done. The next is but2ene. 1, 2, 3, 4. But1ene actually. This is my compound. So in this I have to make it something like this, right? So that means I have to add I here actually. Correct. So if I use HI here now, I just add HI. So in that case, first hydrogen will attack here because it will form a stable carbocation here, right? And I will be added here, but I don't want that. I want I to be added here. So first let me react this guy with HBr in the presence of peroxide, right? Anti-Marconi rule. So with that I'll get is Br, and this is what I'll get. Once I got Br in this position, I can use NaI in presence of acetone, right? So the same reaction. So what I'll get is Ni, and that is my answer. Correct. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.